Thank you. Perfect. Let's go. So, let's see the agenda. We will talk just very briefly about the topic and what this presentation is all about. Then a bit of introduction about who I am. See a few terminology in programming so you are getting used to the things we're going to talk about. And then we're going to analyze the tech roles, which is what you're all here for, I guess. Then see a few methodologies, how tech people work together inside the team and outside with the business to deliver successful software. So let's fix the tech gap. It took me a while to make the title, but what I want to say by that is I want to give you back an understanding of how tech people work and what each role can do so that you, when you go and work with them, can ask the right thing to the right people. And this will hopefully eliminate that gap between the business and the tech. Who I am. My name is Konstantinos Panteli, and I am from a small island, Cyprus. Cyprus is an island in the Mediterranean Sea. It's very sunny. It's like 330 days of the year is sunny. Compared to Czech, that's a different ratio. But that's where I was born, and I grew up until I was 18. When I was 18, I decided to go study software engineering, programming. I didn't do any programming before. I just knew what it was, but I wanted to know what it is and become a professional programmer. That was my dream. So I went to the UK, to Sheffield, and I studied for 3 years as a software engineer. This gave me an introduction of what programming is, how we develop a website, how we develop applications, and then hopefully land a job as a programmer. On my 3rd year, something happened. There was a spark that told me, there's another field in computing. That field was data science, or let's say AI. And it was rising. It was around the 2020. It was COVID, 2021. And at that year, I decided, okay, once I finish my undergraduate, I go to do my master's in advanced computing in the field of AI, artificial intelligence, just because I wanted to know what the role was about. I did my master's. I finished in the University of Manchester for 1 year. But then I said, it's not that nice as a field for me. I prefer the creativity that programming gives me from creating a website or a web application was more real. Because with data, you work a lot with CSV files and different formats that we will see later on that it wasn't the right fit for me. In the middle, you will see, before we continue, you might ask why I'm here in Czech Republic. Well, after I finished my master's, I went to London to find my first job. And I found my first job as a software developer, full stack software developer. Once I got my job, the funny thing, in that summer, I found my love as well, Lily. And that's the reason I am here, because I found the job, and at the same time, I wanted to be here in Czech Republic. So I had to do something to be able to maintain my job and maintain my relationship. So I was able to speak to my manager and arrange something like a contract to work fully remote. And for the last 2 years, I'm here living with my girlfriend. She's the best support I could ever ask for. And I'm working in the same job I found as a full stack web developer. And I built fintech web applications. Basically, it's websites that are dedicated for finance. And you also see in the middle there, that's my setup. I have an obsession about setups. It grew up since I was a young kid, and I used to play video games, so I really like to have a good setup, PlayStation monitor. And over the years, it developed, and I have a page called DevLab, where I share my daily life as a developer And also, I have hundreds of pictures of my setup and things that I get for collaborations, sharing those things. And on top corner, it's my new adventure in YouTube. Recently, I started to make YouTube videos, and you can find more about me there. Finally, I have me pushing some weights, which is part of my life. I spend hours and hours in front of the computer, and through my uni years, and even until to this day, I go regularly to the gym, and I have evidence of people here who see me there going. So I really like to stay healthy and fit to enjoy life. So we will start with the basic terminology now. Thank you, Lily, for telling me to drink water. While we're gonna do this tech talk, she will give me like advice and support, so thank you. So, what is this? Does anyone know? It's 0. But for us, it's a number. For computers, means false or off in a switch. What is this? This is 1. But for computers, this is true. It means on. Computers use zeros and ones to make decisions, and they use a lot of them, like thousands, billions of them. This, for you, is just a bunch of zeros and ones, but for computer, it has something more than that. It stands to, if you convert it with ASCII, to these following characters, H, E, and Y, hey. Now, the brain of the computer is the CPU, the central processing unit. This thing is now this little chip that we all know, but it used to be a huge thing. Like in the 60s, 50s, it was a whole warehouse. Now it's just this little thing that can execute a lot of instructions per second. How many instructions per second do you think it can execute? Does anyone know? You can shout, guys. Nobody will know who shout. Trillions. Not yet. Billions with a B. We used to have like thousands in the 60s, and over the years it grew to now billions. Maybe we have trillions and I don't know about it. But what I know for sure is billions. And this is the foundation of computing. We start with zeros and ones. However, now we have something more that we use to make more sense, because we couldn't work with zeros and ones. We needed something more to do. And that's where software came, which is what tells the hardware what to do. It's basically, it's the program that tells the hardware what to do. And what's a program? It's simple. It's just a set of instructions that we have line by line listed there. And who is doing programs? Who is setting these programs? We have a science behind this, and that's called programming. We, the people, the tech people, are using programming to write instructions for computers to work. Those instructions, usually you heard them as code, and people have a difference between what's programming, what's coding. Well, in a nutshell, coding is when you solve a problem, like in a language or in a task of a program, of a software. But programming is the whole area of creating a program from zero, from an idea to reality, to a website or an application. So it's the whole process. Now, as humans, we have a lot of languages, and we also have a lot of programming languages. We use these languages to develop software. People ask me a lot, especially through my socials, like what languages I need to learn. I need to know Java, I need to know Python, I need to this. There is not exact language that you need to know. You just need to understand how programming and the thinking of programming, and learn some basic ones, and over the time understand what do you want to build. If you want to build a website, you use that language. If you want to build an app, use a different language. And all of these ones are used to create software for these devices. For a phone, for a tablet, for a laptop, for a desktop, any device possible has software behind it. And some guy, some programmer, developed the software for that. Now, software doesn't mean hardware. We can fix software issues, also known as bugs. It's called bugs because the first actual programming issue was a big computer and there was a bug inside of it. So that's why we call it bugs throughout the years. But we can't fix your printer. There is some person who can fix your printer, but we don't want to. We might be able to, but we don't want to. That's something I wanted to mention. It's like a personal thing. Now, a few more words and things that I want to explain so that everyone understands, because we're gonna look at them afterwards in the presentation of the tech roles, so it's more clear for everyone. What's a database, DB? It's basically where we store and we manage and we retrieve, I mean getting data. And that's very important because most of the software use a database. Not every software, but most of the software is using a database. Now, what's an API? Because you're gonna hear a lot of this phrase and the word, it connects software programs together. Imagine of set of doors. Each door has on top a label. And that label could be coffee, wine, beer. You go to the door, you knock on the door, and you ask for, can I have 2 coffees, espresso? That's your request going to the API. And then behind the scenes, there's a barista doing the coffee, and then he opens back and he gives you the coffee. That's the response. In a nutshell, how APIs work. You're gonna see APIs in a website, in a real world example. When you try to log in, and there is an authentication login from your Facebook account or login from your Google account. That website was built and is using the API from Facebook or Google to get the data of your user to then let you log in into the system. And the software development lifecycle. This is very important as these steps are what we're using even to today to develop software. And we need to go through all these steps, and different people have to go through all these steps to deliver a successful software. We will look at this later on after we analyze the tech roles, and I'm going to show you which areas and phases each role should be responsible for. Unfortunately, some roles are doing a lot of these phases, which they shouldn't, but it is what it is. Now, a bit of break just to drink some water, and we're gonna start with the tech roles. If anyone has any questions, please let me know at any time. We're gonna have time afterwards at the end with questions, so if you don't wanna shoot them now, you can shoot them later. Yep.
Yeah, regarding the programming languages.
Yes.
Like natural languages are like a group family, so you would have like German languages, programming and such. There's some structural similarities.
Yes.
So is something similar also for programming?
Yes, it could be similar to that. For example, let me think of some language. Let's say JavaScript and TypeScript could be, because TypeScript comes out of JavaScript, but it's in a more simple way. And they're very similar. And I think once you learn one language, which is a functional language, like Java or C, it's the best way to learn a language and then go to the other ones, because usually the other ones will follow. Some of them are for design. For example, CSS and HTML is just a page, the web page. CSS is how the web page looks. So depending on that, you learn the language, but they have a lot of similarities on also their structure. However, they are different. Thank you for the question. Really appreciate that. So, who is behind tech? We have programmers, also known as developers or engineers. That's how we call them. Then we have, these are the people who write the code or do the programming. Then we have designers. These are the people who design the UI, the user interface. Then we have the testers, the people who make sure that the program functions well before it goes to the people. That's so important. It's super important. Database specialists, the people behind handling the data and the databases. Then we have data experts. These are the people and the roles that I had to face if I would follow my master's degree. Then we have IT people. These are the more general people that we're gonna see who they are. Systems pushers is basically the people who release the software to the websites or apps. And then we have cybersecurity, which I'm not an expert on. We're just gonna go very briefly to that. Whichever roles I'm not very familiar, I'm just gonna be honest with you guys and share my very brief knowledge about them. So we will start with programmers. And I found a few roles which I want us to go through. Front-end, back-end, full-stack, mobile developer, game developer, and embedded software engineer. Ooh, maybe I should have the microphone here. But I don't know, if you still hear me, let me know, guys. Okay? So, let's start with the front-end developer. Front-end developer, he's working with the UI, the user interface. The user interface is what we see once we open an application or a website, what you see, the menu, the buttons, everything. And they are the ones to set up those buttons, tables, everything that you see on the UI, and also are handling the CRUD commands. What I mean by CRUD is create, read, update, and delete. Those 4 commands, I will say, are the most important commands because usually you're gonna have to handle data to do those 4 things. And they need to optimize the performance of their client-side application. What I mean by client-side application, they are the ones building websites, and they do only the front layer, which is what we see, and they are using your machine's power capabilities. So they need to make sure that it's quick and it doesn't take a lot of processing power. And I have a reference here just to share a bit of the structure to get the idea. These are the tasks they are doing. This is a reference I found. And these are tools and languages I found relevant to the role, picture, title, and the category, just to go through it. And Omar, he just reacted to my story on IG. He said, I develop clean components using React.js as a front-end developer. He means that he's creating clean components. Components are like buttons or a form or a table with React.js is a programming language. And I will mention it later. I will continue with the next role. Backend developer. These ones are the ones in the layer between the database and the front end. There's a middle layer which is called backend. Backend is where the logic of a software is happening most of the times. There's still some logic in the front end that you need to set. However, in the backend is where we create controllers. Those controllers, each and every controller, is connected to a table in a database. The database table can have customers, users, sales. Each controller is connected with one table to do the CRUD commands: create, read, update, delete. And of course, they need to do a lot of test cases, because if they don't do test cases, their program will fail, and we don't want that. I wrote the reference for this one, and it's simple. I get requests from people, like I mentioned before with the knock-knock, I want 2 coffees espressos. And I respond back with a JSON object. A JSON is not a person, it's an actual entity which stores key and value, meaning coffee, this, or sorry, that's a bad reference. I will say, how much coffee? 2. And then also the status, which means if it's successful, if it's okay, or if it fails. For example, you can ask me in that door, I want an iced tea. Well, if I don't have iced tea, I will give you an error. I don't have iced tea. And that's how it works. These are some of the languages we're using behind the scenes. I'm working as a full stack developer, and I'm working with Ruby behind the scenes for reference for the people. And full stack developer is my role. And it's basically when you hire one person to do the job of two. Because this person is doing the front end and the back end. It's usually a good role to mix those two things because these people will be able to do quickly the website from scratch to zero to delivery. And as you can see here from my reference, they work on all the layers from an idea to a whole deployment. And even I do deployment, which is not something you see usual, but we do. Mobile developer. Does anyone have any questions on the full stack developer? Because if you have any questions, I would like to answer them now that I have them fresh. No? Okay. Mobile developer. Mobile development is something that I'm doing as a passion on the side. I'm doing my work as a full stack developer, and mobile developer is my passion, which I do on the side. Maybe in the future I will work as a mobile developer. We will see. And it has two categories, the native ones and the hybrid ones. One sec. So a native developer works with one code base, and to one system. So for example, he will write Java or Kotlin to create an Android application. He will write on Shift, another language, to create an iOS application. Or the hybrid way is to use languages like Flutter or React Native with one code to build for two systems. So this is good for companies who don't have much liquid to hire one person to do the code for two. However, it has the pros and cons as you expected. Native development is much, much stronger than the hybrid one. You may find limitations, and based on my own experience, because I work on both native and hybrid on the side, there are limitations. Now, the whole point is to go against the big app stores, the big stores. That's where the game is, because once you finish your code, you have one more problem. On the web, you don't have this problem. You can just deploy your website on a server, buy a domain, no problem. But here, you need to follow some rules that Google set or the Apple Store set. And from my own experience, once I released my first iOS app, I had to do review with the app 14 times. That means I was pushing it, no. Pushing it, no. Because they wanted specific things in the app. They are checking completely. From Google's side, no problem. Once I released it, it was like ready to go. Boom, boom. Okay. Game developer. Game developer, just to analyze it here, is not the same as a game designer. Game designer is someone who designs the maps and the characters. Game developer is more focused on the logic of the game. And it's a role that really fascinates me, as the more I grow, the more I see the role, and I'm inspired by the people working in game, because it's not just, we see games and we think, oh, it's for kids, but there's a lot of logic and work behind the scenes that's amazing. And growing up, I realized that, and I used to play video games like WoW or Call of Duty, and now I see them from a programmer's perspective, how to develop them, and they are just insanely harder than normal programming we do with websites and stuff, because optimization is the key here. And one more thing, everyone can start doing game development with a bit of YouTube tutorials and something like that, and then you just need to figure it out. It's harder than programming, so it's not gonna be easy, but you can use some game engines to develop something quickly. Even in this afternoon, if you go home and start to search it, you can start building something. So don't worry if you don't have a degree on this. I believe that you can just figure it out and do something. An embedded software engineer, this engineer can also be called IoT engineer, Internet of Things. He's the one responsible to creating software for devices that we see outside, like in a train or the traffic lights. So they are going to hardwares and small devices. We call them Raspberry Pi, but there's a lot of devices that they program on to do things that we need so that the society works. Because we need the traffic lights, we need the tram to tell us when is the next stop. They are the ones going behind the scenes to do that. That's all for the programmers. Any questions on that? No? We move on to the designers, UI, UX, and product designer. These are the two main roles we're going to analyze. UI, UX. So UI, UX stands for user interface and user experience. Like we said before, user interface is what we see, all the buttons, how it looks, why is it that color, and so on. And then the user experience is how does the user feel using the software? Is it easy to navigate through the system, or is it hard, is it chaos? And it's so important as a role because developers can think of solving a problem, but from their designs, they could create a lot of problems from the users to use their system. So these people are here to analyze the behavior of the users with the system and get feedback to say, you know what, this button should be in that side because it follows a pattern. So they are the ones to create wireframes and prototypes. And these wireframes and prototypes have developed so much that it looks like you have the real thing, but it's not working. Then the developer needs to go behind the scenes to add the logic, So it just looks that it's almost finished. And they do a lot of tests to improve the designs, like I said. Now, the product designer. This person is more involved with the business and is gathering, in a way, the requirements for the business needs for the software to work. Not just to look nice, but also to be really, really useful. Because we can be a lot of passionate about the software and think like, oh, it looks very nice, it has to be good. But no, these people would come and say, you know what, it's unnecessary. We need to stop it and be efficient and make sure that the software is simple, to the point, and does the work that we need. So they translate requirements into wireframes as well.
Can I ask
Yes?
So I see some overlap with what we at our company call product owner.
Product owner is different. We're gonna see him later on at the methodologies, but very briefly. But you can ask me the question. What is it?
I just saw some overlap in the responsibilities, so I wanted to ask how you're using the term, but if it's gonna be
Product, yeah. I think product owner is more involved to have the software. He owns the software, so he has a bit higher hierarchy level, let's say. Product designer is more focused on how it looks, and it's closer to business. So he can be with the product owner. The product owner will be arranging meetings for all of the designers or the development team together. So we will see him afterwards, I think at the end, at the Scrum. So hold on that. Now, testers. We have 3 main testers that I put here. There's a lot more, there's a lot of categories, but I'll go very briefly through them. And the first one is the QA tester, quality assurance. This person makes sure that he breaks things before the users breaks them. He makes sure that the code is developed and is not being able to be broken by different scenarios of user using the code or the software. Then we have the UAT tester. It's called user acceptance tester. And he is the final barrier between releasing a software to the users. So he's involved to do all the final checks before the software will be released. And then we have the regression tester. This person is involved to make sure the whole software still works okay, even with new things coming in. Because you can add new things, and adding new things can break old things. So this person is involved to check that everything behind is working okay. Now we're gonna move to database specialist. Sec. Do you have any questions on the testers?
I have another one.
Yeah, tell me. You are the best.
Sometimes I hear the term like insanity testing. Does it overlap with
Sanity?
Sanity, like being sane or insane. So the noun from it is sanity or sanity.
I'm not really sure about that, but I can come back to you. Go check it if it's related to this. Maybe it is.
Maybe it's our special jargon.
Yeah, there's a lot of terms that the business are using, so it could be, but I will have to have a look and come back to you. But thank you. Database specialist. And we're gonna go through 3 main roles. The last one, cloud engineer, I put him there as he was closer to the category of the role. And then the 2 on top are database administrator and ETL developer. Let's start with the database administrator. You can see from the picture, it's someone who has a lot of stress because he is handling things which, if you do something wrong, you are screwed forever. You don't want to mess databases, and it's something that people can do, especially junior people, and we need to have this old people to make sure we don't have this problem, okay? They are managing large databases, and I'm saying large like big stuff, and applications that have a lot of traffic, and they ensure that those data are available at all time while having backup of the data. So in case something gets lost, we can retrieve the data. And also they are handling a lot of the data migration. Maybe not fully involved with the data migration, like engineering aspect, but they will be somehow involved with how the transfer is going to happen. And handling data migration is a whole science. You can have a look, there's a YouTube video which shows how, I think it was Uber, they transferred their database from one place to another. It's a whole science behind it, and it's really fascinating how this process happens. It's insane. Now, ETL developer, extract, transform, load. I will explain this with an example. So we don't, if you can see the slide, but I will give you my example. Imagine a chocolate factory. And in that factory, we have white chocolate, black chocolate, and all the types of chocolates. And we want every month to know how many white chocolates we sell. This person will go collect the data from the databases, and because these databases could be having billions of records, okay? It could be the chocolate company Kit Kat or Mars. And they will be able to extract the data, put some business logic with SQL. SQL is the language we retrieve data from databases, and then transform it so that people, the business, can create reports, monthly reports, so they can know every month how many white chocolates we sold to that customer, or if we sold above 1,000 white chocolates to that customer for that month. And also all the logic, it continues like that. Then we have the cloud engineer. And for this one, I have to first explain what is the cloud to everyone. Think of the cloud as electricity. We have electricity here, okay? And think, how do we get the electricity, and how is the electricity being made? We really don't care how the electricity is made. We have generators, windmills, and all this stuff that give us the electricity. So cloud is the same, but in computing power. We have at the end of the month a bill coming in, but instead of paying electricity, we pay computing power. And the cloud has a lot of servers, basically computers, powerful computers all together connected, working for us. And we call it, we use it, and this guy, cloud engineer, he's specializing at connecting the business with the cloud. A few cloud providers are AWS from Amazon, Azure from Microsoft, and I think it's Google Cloud from Google. And they are responsible to continue this CI/CD is very important. It means continue integration, continue deployment. They're responsible so that the software is constantly up and running, and they can constantly update it at any moment that they want. They are the ones in charge to set up the whole plan, the, let's say, blueprint of how these connections happening with the business and the cloud. We move on to data experts. And first, before we move on to data experts and the next roles, we will see a few graphs to understand what they're doing. So, this is the data science lifecycle. And it starts with identifying a problem that the business has. Then we have a bunch of data that we need to collect. These data, unfortunately, are not perfect. We really need to work with them. Like we need to fix the records, remove some duplicates. Duplicates is when we have twice the records. Or some of them are outdated. They don't have a they're not valid, let's say. And we do the data processing, then we do data analysis to make sure that we have everything set, and then we do our data modeling. Data models are what we use like a magic box to solve that problem, that to give us like a prediction of what actions to do. So it has a lot of connection with AI, how the AI models are working, and then it's deployed. We're gonna go through the data expert roles, and then I'm gonna show you, for example, which phases each expert in data is involved. The first one is involved definitely with the first one and the fourth one. And it's the business analyst. Then we have data engineer, data scientist, and machine learning engineer. Data business analyst, He's the one who gathers the information from people and the systems. So he goes to people, understands the problem, and goes to various systems to collect data from. He also needs to understand the problem as the business understanding, so he can go to data engineers and data scientists and translate it to them. Because sometimes we cannot speak well together, tech people and the business. And also they are very good at visualizing the models, which is what we create, to the business with real numbers that make sense to them. Because those graphs, you will not make sense if you are not involved into tech. You really need to understand them. Data engineer. Data engineer is a role I did as well, but during my studies. So when I was in Manchester doing my artificial intelligence postgraduate, I had as a dissertation to create a classification model for people who have brain tumor. And what the classification model is something that can categorize something. So the brain tumor can have 4 grades: grade 1, grade 2, grade 3, grade 4. And this model I developed was able to get a picture input and then output what grade was that picture of that brain tumor based on many things, based on features that they have. And I had to do a lot of cleaning in the raw data. I had to find grade 1 brain tumor, grade 2, grade 3, grade 4. Because when you do the training, you need to have all these things clean so that the model learns into these things and understands to then be tested in real things and get things done. Data scientist. This person, he can be involved with all the steps along the way, he can actually replace every role and do everything. But he has something more than the machine learning engineer. The machine learning engineer is focused on developing the model. This guy can do tests. He can come to a business and say, if the business has this problem that I will say now, we want to get more of our users to be paid. He will think of a way to test this without even doing much of a code, just by changing the UI or things. And then he can also do machine learning model. He can also do that. But usually these people are thinking and doing A/B tests around data and understand the business and go through all the development life cycle of data science. And now we have the machine learning engineer. This person is involved of creating and writing the code where models are made that can do predictions. Basically, when we speak with ChatGPT and it responds and all this stuff, it's a model that's behind trained and knows what to say based on what it learns. One example that I can give is, imagine an app. This app is a taxi app, like Bolt or Uber, and it tells you your driver will be there in 10 or 15 minutes. However, that 10, 15 minutes didn't just came out of the blue. It had features thought about. Those features can be the weather, traffic, or how the streets are at that state. And for example, if there's construction happening to that street, it will know that it will take longer for the driver to come to you. And this data needs to be sometimes trained on a daily basis. That's how quickly data are changing. And I'm sure those apps, they have that. IT people, systems administrator, and system support. These are the people you know most likely to do you the services for support that you need. So I'll start with the system administrator to have a look on him. This guy, he's involved with setting up the servers. Sorry, when I said before they help you, is the system support, which we will see afterwards, after the system administrator. This person, he's setting up the servers, the server racks. Think of when you go to the mall and you go to eat, you have those racks where you put your food once you're finished. Imagine this, but inside of it is a computer. That's how a server looks like. Each rack has a computer, and these people are going there to install the operating system, Windows, Linux. Then the operating system is the main source where software is being built around. And then they install applications, the database, and then they monitor it so that everything runs smoothly. Also, one more thing, they handle the user's permissions, like who has access to what data, so that there is some security between the data there. So they are the jack of all trades, master of none. System support. The picture is not by accident there. Usually these people age much more quickly, because they need to face things that I wish not everyone would face. They need to translate people's requests that doesn't make sense. Like, why does my printer do not work, or why I cannot send an email and all this stuff. So they are the people to fix computers and their issues through email, phone, in real life, in any way. And they have to document their process, so they raise a ticket usually, what the problem is, so they can identify, so they can say what they're doing and how they work. And I wish good luck to the people who are system support. They have to do a lot with Jira, Teams, Outlook, emails coming in. Big respect. Now, let's have a bit of break, guys. This is the system pushers. DevOps is an important role, but let's have like 2 minutes break now. And does anyone have any questions? If not, you can have like a 5 minutes break. If you want to go, you can free to go. or if you want to have a snack, you can go have a snack now. So we're gonna have like 5 minutes break, not 2 minutes break. Thank you. So we continue with the system pushers. I think the title says it all. They just push systems up. We have this DevOps loop here, and it's a process that people use to push updates into software systems that already exist. And we use that because it helps a lot the development team, the people who are programmers, and the people who are the business to release code quickly. Because releasing the code is another process, as you can see, and these DevOps engineers are here to help us do that. They start with the planning, so they said, what are we gonna change, the objectives, the goals of what this release is gonna have. Then we start to create the code, and this code is gonna be in a repository. A repository, which is used by Git, is basically, think of it, different versions of software so that different people can work on it. So one person works on one update on this branch, the other person works on the other branch for the other update. Together they are collaborating. And then they do the testing. They do the test to verify that all the updates are okay and ready to go. Then we have the packaging. And I have that whale there, the Docker logo. Basically, packaging means that you assemble the software and prepare it to be uploaded into the cloud so that it can be accessible to all the servers and all the places that your software is hosted. Once it's been uploaded to the cloud, it needs to be configured. So just by being uploaded is not enough. It needs to be starting to run, and then they monitor it to see everything runs okay, and this cycle continues on and on and on, bridging the gap between development team and operations. We have two people I put here, DevOps engineer and site reliability engineer. SRE, just to go quickly through it, is the person who is making sure that their website is always on. It's on Black Friday. It's on Christmas, on New Year's, the days that there could be a lot of trafficking. They make sure and they give that approval that this website is always on, ready to give their service on. DevOps engineer is what the person we talk about with the whole release process. They are the ones who create scripts and use tools to have the continuous integration, continuous deployment process, so that all the time the software is live working and they can push updates. Because back in time, this couldn't be happening. I was playing a video game called WoW, and they had to put the servers down on Wednesday morning for the developers to push update. But now we don't need that. Their website is always on, and you get the update once you refresh and so on. And they are setting up and maintaining the servers, networks, monitor everything that goes okay. And they, like I said, help developers and operation teams work together. Now, cybersecurity. Very quickly, because I'm not a pro, ethical hacker is the person who goes into the system and sees all the vulnerabilities of the system. Any backdoors that they can access people and provide fixes so that those doors are closed. Nobody can access it. Security engineer is doing that, but in the code. He's the one who is going to check and report and test everything that's safe to go. And then the IT auditor is more involved with the process of the whole security. Do we have the right way of working with the development team, with the operation, everything? When we go live with the website, everything, all the process is safe. So they are the ones to check the whole process, audit it, check it, and then approve it. Now, we are back to this software development lifecycle. And you can see we have the planning, analysis, design. Planning is when the idea comes. Analysis is when we put it into conversations and people discuss, put their opinions, and so on. The design is where we do some prototypes, some wireframes. Implementation is where the code happens, where we develop, write code, program. And then we do the testing to make sure that the software is ready to go. We do a final evaluation with the business that, this is what we expected. We didn't get an elephant and we wanted a tiger or something. That's a very bad example, but let's continue. And then we release the code and then we support it. We need to constantly support because there could be changes. And this happens to everyone. And yeah. So these are all the categories of roles we saw before. And now we're going to see who is involved to what. Programmers, in a realistic, nice world, should be involved with the deployment, with the implementation, get some designs and then work on the implementation, test the code. Then evaluation should be happening with the business and the system pushers. And then they are going to be working a bit with the release and the support. But however, they're working in everything. They have to do sometimes the whole thing, even project management. Project management is like when you are involved with managing the people of the project, but this is something that a manager should do, not a programmer. Now, data experts. These people are not involved with the software specifically to be coded, but they implement the model. So they are doing implementation, but not for the software. They are involved with the planning, analysis, and design. Like I said before, they can do A/B testings to check what if we use these users to do this action to increase something that we want. And they, of course, are involved with the testing and evaluation of their model. So once their model goes into the software, they test it, it works. And does it do evaluate it? Does it do what the business wanted it to do? Does it predict correctly the time that the driver has to come to you? Then we have the designers. The designers are involved with the planning, analysis, and design, and of course the evaluation, because they need to see at the end what's going to be released is what they expected and what they designed. If they draw a house, not to get a garage, let's say. Then we have the testers. They are involved with the testing and evaluation, but also the design, because they really need to know what was going to be released so they can see a bit of the prototypes and wireframes to get the logic to make good test cases. Because you can make tests forever. You can go on and on and on. Your test cases have to have a logic. So they have to be involved with testing and evaluating with the right designs. Then the database specialists are there to support because they need to make changes to a database or records and so on. Planning, analysis, design, and implementation, because they really need to know how the business thought of making a system, and then if it's possible to create the relationships in the database. Database is full of relationships between tables, and they need to know that those relationships are possible and are efficient for the solution that they design, the business design with the programmers and so on. And then we have the IT people who are mainly involved in the support, except the system administrator who can do a few other things. But let's say they're more involved with the support. Systems pushers, like their name, definitely evaluation, because they will act as a police. They will get the code and say, if it wasn't tested and verified well, we will not allow this code to be passed to be then released. Maybe they can also be part of the planning, because they will have to do this whole loop there, but it's not for the development, it's for the process of releasing the software. And cybersecurity, they're involved. They need to know the design, the blueprints, to understand, to see any vulnerabilities. And then they will be involved with the evaluation, release, and support. Release, because once it goes live, it goes to the right direction, and it's accessed by the right people, not to anyone. So that's their job. What about IT managers? You heard these names like CIO, CTO, VP, IT director, tech lead. They are involved with the people. I don't know, I'm not a manager, so I guess based on my experience, they are working to see that the projects are happening, that we have the right deadline, and they manage the people so that everyone is doing the right job. They can also identify what each and everyone in tech can do and what's their specializations and what's also their hidden talents, because they need to bring them out of it. And really, that's what they do. And in percentage, I will say they do 10% code maximum. Maybe that's a lot. 90% management of people projects. Now we're going to move on to methodologies. And these, do you have any questions with the tech roles? Because now we just finished the tech roles. We're going to go through a few methodologies and approaches that the people, yeah.
So you mentioned that you are working as a full stack developer, and you mentioned also role of DevOps.
Mm-hmm.
If you do some smaller projects, what is the possibility that you are overstepping these two roles? Because if the project is not big enough, you are probably
gonna be doing
the DevOps.
Yes. For example, in my team, I'm doing a lot of the DevOps part. I'm pushing the code to mainly up to dev side, because we have a development side and a live side. Then the live side is only done by the manager and the higher developer. But usually it shouldn't be that. It should have a whole team that gets all the updates coming in from the repositories, like from branches, and also have a whole process of approving that and a lot of steps. But if you are a small team, you might not be able to afford this. And we need to do things quickly and in a junky way because it's cheaper, let's say. But if it's a big enterprise, they definitely have DevOps and everyone in place, so there's a better control and monitoring of what's going up and down. Once you are a small team, this can work. But once you are like 10, 15 people, you definitely need DevOps. So he can be the policeman, manage who is going to push when, because otherwise it's going to be chaos. But very good question. Does that answer your question?
Yeah, sure. Thanks.
So, methodologies, how are projects managed? I just put these four as the main ones to analyze. There's a lot more, but these ones I would say are the main ones to just go through. We have first the waterfall, agile, which is very important, Kanban, and Scrum. Waterfall. This is when the process and the phase that you are becomes mandatory to be finished before you move to the next step. For example, in any project, you're going to start with analyzing what the problem is and setting up down the tasks and objectives of what your software is going to do. And then you do the designs like a blueprint and prototype and wireframes to know what your software will solve. Then you move to implementation, where you do the coding, testing, deployment, maintenance. And this was being used for years to develop software, and it's a standard way so that you are secure, you don't avoid any step, you make sure that you finish. However, sometimes things can change. Things can change, and in the implementation, you might need to do some changes that were not in the design. That's where Agile comes. Agile is a way of thinking of how you work, is where you can overdo it, but I think if you do it the right way, you will bring and deliver successful software. It's how you approach a problem and how you action onto something, and you have a bit of more thinking before you're doing an action. You think as not the product, but as the user who is going to use the product. So you have a set of values and principles that we follow with Agile. For example, you think of people over tools. So you might have good tools and obsessed with using Teams, Jira, all this stuff, but your people need to know those tools and how to use them, so you put priority to that. Then you have product over paperwork, meaning that what you really have as a product, what you have as a website, is what's talking. What you dream or you imagine of creating doesn't really matter. You focus on what your value of your product is, because your product cannot do everything. It can do whatever you program it to do. And it has to be a lot with the collaboration over contracts, meaning you might agree on doing this, but in the development, something could change, and you need to provide that change and not follow just a contract like tunnel vision. Be more open to changes. And finally, that's what I say, flexibility over plan, meaning that you can stretch out and do changes while you are doing the work. Make sure to inform people about these changes if you are not the lead. And then we have a lot of principles that we follow with Agile, like customer first, which is very important. The whole point is your product and your software, you could be a developer who be like, oh my God, this code is amazing, it's so smart. But if the people who use it don't like it, it doesn't matter. It doesn't really matter. It's like you make a good painting, and for you that painting is amazing, I really love it, but people don't like it. The people are the judge. The people who use your software are the people who are gonna say if it's worth it or not. And it has a lot of more principles that you can see there that helps teams do software and have a more thought behind each action so they can improve, stretch, change, and not have a tunnel vision. Now, and this Agile, we're gonna see it later on with a successful software system and how it was used there. Canva is something that I'm using as well lately, and I think it's very, very good. I'm building a web productivity app on iOS, and I'm stuck with having a lot of tasks to do, and sometimes it could be chaotic. So this methodology helps you limit the what's in work in progress. You can see the number 4 there. The number 4 is there for a reason, because you can only have in progress 4 things. You cannot add something more. You cannot remove and have something not finished. Once you have it there, you finish it, and that puts an urgency so that the development needs to focus on that task. It could be specific to the person that's working, or it could be to the whole team. So that gives a good flow of the team and not to have too many things on their plate, which is very good. And now the Scrum. I'll just have a sip before I talk about the Scrum. Don't worry about the graph. I made it based on my way of thinking, but I will try to explain, and hopefully that way of thinking will come into your brain as well. You asked me before about product owner. So here is the product owner. And this guy, along with the stakeholders, they have the software. They are the ones who own it, let's say. They have the license, okay? And they usually get feedback from customers for changes. They list down the changes in a backlog. They give them to the development team. The development team works here, as you can see, the programmers doing their code, and then they push the changes in that product, which is a package, into the customer. However, this workflow was very difficult to maintain. We needed someone to bridge this gap between product owner and customer. And that's where the Scrum Master came. The Scrum Master came. This guy is responsible to do weekly sprints and daily scrums. What's a weekly sprint is when he gets from the product owner this list of backlogs. And this guy, he needs to manage the development team that they are on track. For example, every day he will have a meeting and he will ask the development team, what did you do yesterday? What will you do today? And are there any issues? Are we stuck somewhere? So they will know if somebody is having issues. And he will be more able to connect with the development team because he can understand them a bit. He has a bit of knowledge of what they are working on, as well as what the business needs. So he can connect those two teams together. You see the backlog here has 1, 2, 3, 4. And one of the responsibility is to make this 1, 2, 3, 4 in the right order. So for example, the third one could be the most important task. They will be putting it to the number 1, then it's going to be 3, 2, 1, 4. So it has a priority of what needs to be done. And also, they have two more things. The sprint review, which is when they sit with the product owner, the development team, and they analyze the whole development cycle that they've done, like what we've delivered in 2 weeks or 4 weeks. And if that the thing that we deliver was what we expected from the beginning, what we said to do. And if there's some things that we need to change. And then they have the sprint retrospective, where they analyze with the development team what process we need to change. Like there's some issues that we can see on the daily Scrum that come over and over again. What are those problems? How we can solve them? Please let me know if that makes sense, and if it doesn't, I'm here to answer any questions on the Scrum. No? Good. So, successful software cases. We're going to have a look now at just a few successful software cases, and we're almost finished. 3 successful software that I put here is Airbnb, Slack, and ChatGPT. I think it's what I had in my description, so there's no surprise. We will start with Airbnb. So, what Airbnb did, and it's something that how we approach projects is very important, because they solve a problem very cheaply, and that gave them the boost to continue. Airbnb is a hosting platform that allows guests to host their properties and people to go and reserve the places. These people, in 2007, the owner was in San Francisco, and there was a seminar. This seminar was fully booked, all the hotels were booked, and they said, okay guys, we have 3 airbeds, let's rent them. So we're gonna rent them, have breakfast to the people, make a quick website so someone can reserve. So they made it very quickly to see if their idea makes sense. They did it, it made sense, and then they grow up. Sorry. What's up? Is it okay? I think it's fine. And throughout the years, they use a lot of things that made this software smart. There are a lot of people behind the scenes, from data experts, database specialists. They scale up the application the right way, and they invested in all the workflows that are important. The continuous integration, continuous development, constantly to have the app running so that everyone can have access to it. Because if it's not running, you're going to have a problem. You book something and it's 12 o'clock in the night, you need to check in. Imagine if the app is not available. It's not going to work. So they need to have everything there set, and also everything they decided, and the UI, how it looks, it's so user-friendly that everyone can list their property in just a few clicks. It's so easy, and for the users to guess and the guests to book something, it's super easy. Now, we will move on to Slack. Does anyone have any questions on Airbnb or anything else? Did you know the history of it, or no? It's cool. I don't know how they survived the COVID, because I remember I was listening to a podcast of the owner, and they suffered a lot during the COVID period. So the fact that they are still running after that, it gives you the resilience to someone, and it's amazing, the story behind this. Slack. Also, I used to rent some property in Airbnb. Sorry, Slack. Slack, it's where the agile methodology I was telling you before comes into the game. What I mean by agile, I mean how they change it from where it came from. It used to be a game. Slack came from a game. And that game had a communication service into it, so that different players can talk and connect together with channels and so on. And then they took their tool of the communication, because they say, hey guys, I think there's something more behind this. We can make it as a different product for people to use it. And that's what they did. They made a software, and out of that software, they developed a new software that became super successful. And that's the Slack. That's where people go to collaborate and connect with each other, and it's fun. it's a lot of, it's fan favored by developers and people who are into tech a lot. It's user-friendly, and it has a focus of scaling up to your usage. And this is very nice as a software, because it will give you the free plan, and over the time you use it, it becomes adapt to your usage, and then the membership comes. Thank you so much for listening to me. It's been a pleasure, and I hope that this gives you a bit of sense of the people and the roles and the different methodologies and some successful software cases. Do you have any questions? Sorry, because I will not 404 you, because 404 is like the error you get on the website. It was just a funny thing. I thought it was funny to use. So please let me know if you have any questions. Thank you so much. So, any questions? Anyone? Don't be shy, really.
Do you use something to track your tasks?
To track my tasks?
Yeah, I think I maybe saw Notion. But
yes.
Sure.
No, it wasn't on that.
I'm sorry?
I didn't put it anywhere on the slides.
Yeah, on the photo of you.
Yes, I'm using Notion a lot.
Okay.
I used to use Trello when I was studying, but then I switched to Notion as I can scale up and have it. I learned the software, so I will suggest to use what works for you. For example, if you are not having internet access, it will be best to use some notepad or find a way to track your notes your way so you can understand them. That's the most important thing. And over the years, you will change. You will change depending on your feeling and what project you are working on. I think it's good to change it. For example, for my work, I use Google Docs. But for my side projects, I use Notion. So have a separate way of taking my notes, keeps me more into, once I open it, I know I'm doing that type of work. So, thank you. Yeah.
What task of software development do you like the most and do you hate the most?
Do I love the most? I hate queries, which are for small things, like not very necessary important, but maybe it's because I see it from a developer eye. For the user, it could be a problem. And I really love when I just go away and I have my own sprint of development, no noise, and just pure code, creating my stuff. And every time you get this chance, you get better and better. And every project, you need to think of it and handle it different to improve on what you did before. Because every time you're gonna improve. And I love taking on new projects, and that's my advice for everyone. Take as many new projects and jump onto them like it's your survival instinct. That's the way you should go. I hope that answers to you. Any more questions? Elichka, do you have any questions? Sure? Okay. So, thank you everyone. If you want to find more about me, you can find everything you need to know to my website. And in my website, if you scroll down, you're gonna see my LinkedIn, my YouTube, everything you really need to know about me. Thank you so much for your time, and have a great Christmas and Happy New Year.